Hello, geometry ladies and gentlemen. Today we're going to be talking about trigonometry applications, so real world problems, and then the inverse trig functions. I do not have a foldable for you, so you're going to have to write all this stuff down in your notebook along with what I write. Remember, every slide that has a pencil written on it is what you're going to have to write down. So what you'll need today is a calculator, pen or pencil, and your notes. So we're just going to go right off the bat with 3 examples. So if you want to write down the full word problem, you can. Otherwise, just draw the image and everything else. So at a point on the ground, 50 feet from the foot of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. So our picture would look like this. And when we say angle of elevation, here I'll highlight it in a different color, the angle of elevation, that means that from the ground looking up, that angle, which is this angle right here, from the ground looking up to the top of the tree, that angle. So we want to find the height of the tree. So this would be x. So remember SOHCAHTOA, we need to figure out if we're going to use sine, cosine, or tangent. SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we're not going to use sine or cosine, right? We have opposite over adjacent. We don't have the hypotenuse length. So we're going to do the tangent of angle 53 is equal to opposite, which is x, over adjacent, which is 50 feet. So what we want to plug into our calculators is 50 times the tangent of 53. And remember, for now, we're going to round these decimals 4 decimal places. And we get for an answer that the height of the tree is approximately 66.3522 feet. So that's approximately the height of the tree. So our picture is a little bit not drawn to scale, but that's all right. Moving on to example number 2, in Washington, D.C., the Washington Monument is 550 feet tall. If the angle of elevation for your line of sight is 75 degrees, how far away are you from the base? Your eyes are 5 feet from the ground. So this is what our image should look like when we draw it out. There's the Washington Monument. It's 550 feet tall. But we also have to keep in mind that our person is 5 feet from the ground. So the height of the base of the monument to the top is 550 feet, but we're talking about the line of sight from our eyes to the top of the monument. So we're actually going to use 550 feet, right? Because this is 5 feet for the height of the guy, also tacked onto the monument. So we need to figure out the distance we are from the base of the monument. So we're not going to find the hypotenuse. So again, we're going to need to use tangent. And remember, my 75 degrees is an angle of elevation. That's why it goes right here. So we're using tangent of 75 degrees is equal to the opposite side length, which we found out is 550, not 555, because we're 5 feet tall. And we're talking about our eyesight here to the top of the monument, all divided by x, because that's what I want to find, the adjacent side to my 75-degree angle. That's what we want to know. How far away are we from the base of the monument? So in order to solve, remember we have to multiply both sides by x to get x out of the denominator. It'll cancel the x's on the right-hand side. We get x times the tangent of 75 is equal to 550. But now we have to divide by the tangent of 75 in order to get x alone. And that's what we're going to plug into our calculators. 550 divided by tangent of 75, we are approximately 147.3721 feet away from the base of the monument. And that is my answer. Moving on to number 3, a 60-foot lighthouse sits on top of a 150-foot cliff. The angle of depression to a boat is 27 degrees. First, I'm going to note that we have an angle of depression, so I'll talk about that in just a second. And we need to find the distance from the boat to the base of the cliff. Okay, so let's first draw a picture. So we have a 60-foot lighthouse, so this is 60 feet, on top of a cliff, which is 150 feet, and then we have some waves, and we have a boat sitting out here, and they told us from the lighthouse we have an angle of depression about 27 degrees. So if the light were to be shining directly straight out into the water, making a 90-degree angle, we're saying that the angle of depression on this guy is this angle right here. I don't think I made that very clear when I talked about it last week, but an angle of depression, when we say it's looking down, if you were looking straight ahead and then looking down, that angle that it's creating. So it's this angle right here. So this is our 90-degree angle. We know that if this was a 90-degree angle, this right here, we take 90 minus 27 to get 63 degrees there, and then my other angle down here would be 27 because 180 minus 90 minus 63 gets me back 27 degrees. So those are the three angle measures in my triangle. All right, knowing that, we also know that the entire height from the shore, or the water, I should say the water level, to the top of the beacon of the lighthouse is going to be 210 feet, because that's just simply 60 plus 150. So, question now is, we need to know this distance, the distance from the cliff to the boat. So are we going to use sine, cosine, or tangent? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then we have tangent, which is opposite over adjacent. Again, we don't know the hypotenuse, so we're going to have to use tangent. So I'm going to use tangent of 63. So tangent of 63 degrees is equal to the opposite side, which is x, all over the height, which is 210. Remember, we're adding the 60 plus 150 to get a height of 210. So we multiply both sides by 210 on both sides. So what we're plugging into our calculator then is 210 times tangent of 63 times tangent of 63. Let me just punch that into my calculator. And we get that the boat's distance is approximately 412.148 feet from the base of the cliff. And that is my answer. All right, now let's talk about inverse trig functions. So if you are trying to calculate the angle, you will need to use the inverse sine, inverse cosine, or inverse tangent to solve the equation. On your calculator, it looks like this: sine to the -1, cosine to the -1, tangent to the -1. But we read them as inverse sine, inverse cosine, inverse tangent. So make sure you get this in your notes, and we'll look at an example to see more of what I'm talking about. All right, so we've learned with trig that sine, cosine, and tangent are representing distance, or some side or ratio of sides between right triangles. So that's what sine, cosine, and tangent help us find, is distance. But now when we're solving for theta, we're solving for the actual angle measure in the triangle. So in my first example, this number 1 example, make sure to draw these examples in your notes. We have theta, and the two numbers that were given to us in relation to theta are the opposite side and the hypotenuse. So we're going to use sine. So sine of theta is equal to 12 over 17. Well, now I need to get theta by itself, but I'm taking the sine of it. So the opposite operation, in order to get theta alone, is sine inverse. So we're taking the sine inverse of both sides. So what the sine inverse of sine does is completely go away, leaving us with theta. Think about if we had, let's drop here, if we had x plus 3 is equal to 7. We're adding 3 to x, and if we want to isolate it, we have to do the opposite operation to both sides, right? So we have to subtract 3 in order to get x equal to 4. If we had 3 times x equals 7, we'd have to divide by 3. We have to do the opposite operation. So in order to get sine of theta, get theta by itself out of that sine, I'm taking the sine inverse of both sides. So theta is equal to the sine inverse of 12 divided by 17. So theta is approximately 44.9009 degrees. And we're still going to want around 4 decimal places on these degrees just to be a little more accurate. Okay, now I'm going to do this triangle, and I'm going to call it example number 2 in blue. So I'll do it in blue. So now we have theta, but now in relation to theta, this 12 is going to be the adjacent side, and 17 is going to be the hypotenuse side. So we're going to use cosine. So the cosine of theta is equal to the adjacent, which is 12 divided by 17. So now in order to get theta alone, we have to do cosine inverse of the left-hand side and cosine inverse of the right-hand side. That's going to eliminate my cosine and cosine inverse, leaving me with theta equal to the cosine inverse of 12 divided by 17. Let me just plug that into my calculator. Cosine inverse of 12 divided by 17 is equal to theta is approximately 45.0991 degrees. So those are my two examples, and I hope that helps with a little bit to see how the inverse works. If you're having trouble finding sine inverse, cosine inverse, tangent inverse, those buttons on your calculator, you can bring that up to me in class, and then we can talk about how to use our calculator to do the inverse trig. We just have one more real life example, and this is going to be using the inverse functions. So you are standing at 100 feet from the Statue of Liberty, your eyes are 5 feet from the ground, and the statue is 305 feet tall. What is the angle of elevation from your line of sight to the top of the statue? So this is what our picture would look like. Keep in mind, we have to subtract off that 5 feet from the 305 to leave us with a 300 feet, which is this distance to this distance, and that's the triangle we're looking at. And this is still 100 feet. So we again need to figure out, are we using sine, cosine, or tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We have to use tangent because we don't have the hypotenuse length. So that's pretty simple. So we need to figure out the angle of elevation, theta. So tangent of theta. So opposite over adjacent in regards to theta gives me 300 opposite over adjacent, which is 100. That's also the tangent theta of 3. 300 divided by 100 is 3. We can reduce that ratio. In order to get to theta alone, I have to take inverse tangent, or tan inverse, of both sides. That's going to cancel this out. I'm going to get theta is equal to the tangent inverse of 3, or inverse tangent of 3. So my degree measure for theta is approximately 71.5651 degrees. And that is our final example and our final answer. I want to thank you for taking good notes, and I shall see you soon.